Dear OmniSLAM users, welcome to watch our series of tutorial videos of OmniSLAM device operation. In this video, I will introduce to you the operation process of OmniSLAM Backpack R8 Plus. First, let's install the backpack. This is the original state of our backpack. Open the tripod first. Then install the extension rod. Next, install the main module. Install the battery. Next, install the LiDAR. At last, install our GNSS module. Okay, this is the installation process of all modules. Then let's install power cords. We have two types C power cords. This time we use the shorter one in backpack mode. The longer one is used in handheld mode. Alright, this is the whole device installation process. After the installation, we need to turn on all the power buttons. R8 Plus has 3 power buttons. First, we need to turn on the sensor key. Then we need to wait 5 seconds to turn on the master key, and open the camera key at last after 15 seconds. Now I'll demonstrate the process for you. First, we turn on the sensor key on the host. After opening the sensor key, wait 5 seconds to turn on the master key. Then, after 15 seconds, turn on the power button of the camera. Okay, now the camera is turned on. Our entire boot process is completed. After we successfully turn on the device, we need to connect our handheld device, mobile phone, to the device. The first step is to swipe to the lower right corner to open the control interface. Then turn on the Wi-Fi switch to make our Wi-Fi switch turn blue. Then long press and find our device's Wi-Fi. The first one is the serial number of our device, which is the Wi-Fi of our device. Click connect, and our password is 128. Then we enter the browser interface. Open the browser and enter our URL 192.168.95.110.8888. Then we can get into Capture Operation Interface. First, we click on System. And because I need to use the GNSS module this time, so we need to connect to the CORS account. Click Config. Click Switch, and it will turn blue. This represents the Wi-Fi search function is on state. At this time, we need to use our own phone to share a hotspot. After sharing, we click Refresh and find our own Wi-Fi. This is my phone's Wi-Fi. Then enter the password. Click Connect. Then our Wi-Fi name has displayed as the name of our own hotspot. The network connection shows on which proves that we have connected successfully. Keep other parameters as default. Click OK. Then enter our IP. Enter the information of our CORS account, including IP, name, password, port, and node. These information should be entered according to our real account. Then click. It shows us the nodes that we can use now. Then click the node we need to use. And click Save. Therefore, we can use the same account information directly next time. After all the information have been correctly entered, we need to click Init System. Wait for a few seconds. Now it shows that our initialization is successful. Click OK and click Connect. Then the current differential status shows yes, proving that the RTK has been successfully connected. Now, the first number of our RTK status is 5. It means we are not in a fixed state. If the first number is 4, it represents the RTK has entered a fixed state. The middle number represents the HDOP value. The third number represents the number of satellites. Next, we click Project, click Project Name, and enter our project name. The project name can only contain English letters and numbers, and no other special characters. Then, here is the switch for real-time display. We can choose to turn it on or off. Blue means it's on. After turning it on, we can see the real-time point cloud capture display. At this time, we can find a suitable location to start the project. Click Start to start our project. After setting the parameters of the capture operation, we are ready to start our project. Before starting the project, I need to emphasize 3 points. One is that our device must be placed on the ground before we start the project. The second point is that the LiDAR must be facing the effective features. Like in our current scene, the building belongs to effective features. Effective features refer to fixed objects. Then, the third point is that at the starting position, we need to make sure the RTK gets a fixed solution, and the HDOP value must be less than 3. These are the 3 main points to highlight. After all the conditions are met, we click Start. After clicking Start, there is a 15-second initialization time. After the initialization is completed, then our LiDAR will start to rotate. Then you can carry the device and start working. Okay, now our laser head is starting to rotate, which proves that our initialization is successful. We click OK here and start the work. Alright, everyone, follow my camera, and let's explore the entire data capture process together. During the data capture process, we need to keep an eye on the status of our RT. When we finish scanning, we click Stop. Click OK. Then our device will conduct a self-check of the data. Wait for 5 seconds. Now the data self-check is successful. Click OK. The whole scanning process is over. After the scan is completed, we need to copy the data. This is the USB flash drive that comes with our device. Then we insert it into the USB port of the host. Then click Data on the Capture Operation interface. Click Refresh on the top. Select the project we scanned today. Then click Refresh at the bottom. Click Copy. At the bottom, there is a progress bar for our copy. The original file is copied first, then the camera data. After the copy is completed, we will get a prompt. Now it prompts that the copy is completed. We click OK. Click Eject. Then, the data copy is done. After outside scanning, we come back to process the data. First, we open the Mapper software. This is the operation interface of our Mapper software. Click Create. Find the Open button and open the location where our project is stored. In this path should not contain other special characters, only containing English letters and numbers. Then find the index file, click Open. This is the information of our project. In most cases, we don't need to change it, just keep the default. Click Create. Click Settings. Because we use GNSS in this project, so we need to adjust the relevant parameters in GNSS setting. In most cases, we only need to set our source and target coordinates. Our source coordinate system and target coordinate system have two setting methods. First is the general method. For source coordinate system, we need to input the ellipsoid parameters, which corresponds to the ellipsoid parameters of coarse port. For a target coordinate system, we also need to enter the ellipsoid parameters and transform and projection parameters. If the ellipsoid parameters of source coordinate system and target coordinate system are same, then we don't need to enter transform parameters. We only need to enter the projection parameters. In our current scanning project, the ellipsoid corresponding to our coarse port is CGC's 2000, so I don't need to change it. And the ellipsoid corresponding to our target coordinate system is CGC's 2000 as well, so I don't need to change them. And I don't need to enter the 7 params here. There are 3 models for 7 params, including Bursa, simple underscore Bursa, and one step. Under projection, we need to select Gauss. Then enter the central meridian. The default value 123 is correct, so I don't need to change it. And these parameters are correct as well. In addition to this method, we can also set the source coordinates and target coordinates by EPSG code. The EPSG code of the source coordinate system corresponds to the code of coarse port. We can also directly enter the EPSG code of the target coordinates under the target coordinate system. In this way, we can directly use EPSG codes to transform the coordinate systems. Both general method and EPSG code are applicable. We can also enter grid correction. If you have the grid file, you can enter it here, including the value of east, north, and height. We don't need to enter any grid file here, so I don't need to do anything. After setting the source coordinates and the target coordinates, click Advanced Output Setting. Then select the point cloud data format we need. Here I select LAZ because the LAZ takes up the least space, and I select 5 mm under output mode, which is our default. Then click on Remove Moving Objects, Reflection Noise, because if we want to output a clean point cloud, this is a must check. In this way, the moving objects and the reflection noise can be deleted by the system. Now that all parameters are set, click OK. Click Process. Then we just wait for the program to process the data and check the output of the process. After data process, open the original folder. After opening the original folder, there is an extra folder named Process. This is the folder where we place our output. Open Output. This is all our process results, including camera accuracy evaluation, panoramic image trajectory, scan trajectory, and point cloud file. LAZ file is our point cloud result file. And finally, there is our trajectory file. This is the output content of all our results.